Good morning, guys. So right now we're gonna stop chapter 9 currently, and we're gonna jump into chapter 6, which is systems and matrices and such. Now, before we get into chapter 6, I'd like to do a matrix review. Even though we saw that in the beginning of the year, very basically, let's go over everything again. Let's go over the basics right now, because then when we start chapter 6, we're going to be using matrices heavily and with different ways to solve systems and such. It's not that difficult. So let's begin with the concept of a matrix. A matrix is pretty much a collection of elements that are displayed in rows and rows and columns. Now, look, of course, in math we can use variables and such, but mostly, just numbers, and usually integer numbers. That's not necessarily true. A matrix is labeled with a capital letter, and elements of that matrix are displaced in the lowercase letter. Now, we always take into consideration the rows first and then the columns. So matrix A has dimensions of 2 by 3, 2 rows and 3 columns. So matrix A is 2 by 3. Matrix A down here, another matrix, is 2 by 2. Matrix C is 2 by 1. Rows first, then columns. And likewise, if I want to find an element within the matrix, I pretty much write the letter and then, for example, the number. Remember, that does not mean 21. That means row 2, element 1. It would be this one. Row 1, element 3. So row 2, element 1 would be -2. Row 1, element 3 would be -18. So pretty much, again, that's how we name matrices and we write the dimensions. Now, why are the dimensions important? Because in order to add or subtract matrices, they have to have the exact same dimensions. For example, these two can be added or subtracted, but these two cannot be added or subtracted. Think of it like in algebra. You can't add these two unless they are like terms. You cannot add matrices unless they are like dimensions. They have to have the exact same dimensions in order to be added or subtracted. Now let's go over example 2, which is adding and subtracting matrices. First, let's do A plus B. Then we'll do A minus B. And then we'll do A plus C. Now, remember, I'll list the name of the new matrix. And when you're going to add, all you have to do is combine the exact same elements that correspond within the matrix. So in matrix A, I'm going to take the first element in the first row. And in matrix B, I'll take the first element in the first row as well. So 8 plus 12 is 20. Then I take the second element in the first row here and the second element in the first row here. 3 minus 7, -4. Take the first element in the second row, first element in the second row, -5 plus 6 is +1. Second element, second row, second element, second row, 14 minus 23 is -9. And that's how you add. You just combine the corresponding elements into the new matrix. Remember, they're going to be placed in the exact same spots where they were originally. All you got to do is just combine them both. Now let's do a subtraction. The subtraction is pretty much exactly the same, only just like when we're subtracting polynomials, a negative has to be applied. A negative has to be applied within the parentheses. That's what happens when we add polynomials. Negative, negative, positive. The same thing applies to the matrix. I'm going to switch all these signs and then add them. So let's see. What is 8 minus 12? -4. 3 minus negative 7 turns this into a positive 7. So 3 plus 7 is 10. Negative 5 minus 6, negative 11. 14 minus negative 23 turns this positive. We add it, we end up with 37. So this is the resulting matrix of A minus B. All you gotta do is change the sign of the matrix you're subtracting and then just combine the corresponding elements. Now let's do the third one. A plus C. A plus C. Remember I said in the beginning, in order for our matrices to be added, they have to be of the same dimensions. These two are not of same dimensions. So, just say it cannot be added. Or like, just say you can add. Cannot be done. Now, there are two types of multiplications we're gonna go over in matrices. And today we're gonna look at just the first one, which is scalar multiplication. Let's say I take, for example, A is this, and I say 4A, that means I'm gonna multiply this entire matrix by 4, every single element. So 4 times 8 is 32, 4 times 3 is 12, 4 times negative 5 is negative 20, 4 times 14 is 56. And that's scalar multiplication. The other multiplication we're actually going to do tomorrow, and that's multiplying two matrices, A times B. There's a couple of special rules, and it's somewhat confusing, so I want to dedicate tomorrow's entire day to just multiplying matrices in a non-scalar fashion. Again, right here, we're just scaling a matrix. Think of it like when you do a scale model, 500 to 1. That means for every 500 you have in one item, you're going to have one of the other. So you're going to multiply by a scale factor. This is what you're doing. So I scaled this matrix by a factor of 4. The same thing can happen with fractions. And again, you'll just end up with decimals or fractions, but that's fine. So that's scalar multiplication. Now note, we can have multi-step equations. For example, let's do 2A minus B. Again, pretty much PEMDAS only apply to matrices. We're going to do this subtraction first and then scale by a factor of 2. So let's do the subtraction first. 8 minus 12. Let's do this. A minus B. 8 minus 12 is negative 4. 3 minus negative 7. I just erased the other answer. Had I known. Negative 5 minus 6, negative 11. 14 plus 23, because remember we changed the sign, it's 37. And now I'm going to scale it by a factor of 2. That means I'm going to multiply every element by 2. Negative 8, 20, negative 22, 60, negative 74. Oh, positive 74, I apologize. So that would be a multi-step process. PEMDAS to the normal mathematical operations. Now let's do the last one, which is, what we'll probably be doing. We already evaluated addition, subtraction, multiplication the first week of class a while ago. This is just to remind you guys of what we already worked on. Now we're going to do solving. Let's say, for example, that they gave me that A is the following matrix. Negative. And this is example 5 in the book, by the way, page 25. And chapter 0.6 is page 23. Right now, to finish, I'll be doing example 5, which is solving a matrix operation. Negative 9, 15, 4. Let's just break that up to make sure you can see it's a couple of elements. 2, negative 10, negative 5, and I'm told that b is equal to 5 minus 7, 8, and 14, 10, minus 3. Now I'm told the following. 4x minus b equals a. And they tell me solve for x. Solve for x. Again, what you're going to do is you're going to try to isolate your x like you do with regular algebra. Isolate your x and then do the operations you're told in order to find x. So let's see. In order to find x, first, I'm going to add ab to this side. This cancels out. 4x equals a plus b. Then I'm going to divide by 4 here and divide by 4 here, which is the same as multiplying by 1/4. So pretty much my x will be 1/4 of a plus b. Now let's do our multi-step operations. A plus b. I'm just going to do it directly. -9 plus 5 is -4. 15 plus -7 is 8. 4 plus 8 is 12. Again, right now I'm just adding normally. 2 plus 14 is 16. -10 plus 10, 0. -5 minus 3, -8. Now, after I have my addition, now I'm going to scale by a factor of 1/4, which is the same thing as dividing every element by the number 4. So I'd end up with -1 here, 2, 3, 4, 0 divided by 4 is 0, remember? And -2. So I just solved for x. And that is the same thing as x. So it's pretty simple, pretty straightforward. For homework, I want you guys to do 37 through 44, which is just solving. Pretty simple, pretty straightforward, and practice. If you have any questions, please ask. Now, one thing, most of you, I'm very happy, most of you are doing all the work. Some of you are not passing attendance, some of you are not uploading your notebooks, your homework. Now remember, you're losing academic points when you're not passing attendance, and you're losing academic points when you don't upload your homework. I'm giving you until 10 p.m. I'm making sure we have a flexible schedule and everyone can just do the class at their own time. If people stop passing attendance and people stop handing in their homework, we're going to all have to connect via Skype at the hour of the class. So unless you want to wake up Thursdays at 7:50 to be able to connect and do 1 hour of math in the morning, I suggest absolutely everybody upload their homework and take their attendance properly. Okay? Do not lose points in this fourth quarter. Again, these grades are heavily weighted in your favor, so when we get back, you're going to have a good buffer of grades for the difficult classes I'm skipping, because the difficult classes I want to actually give in person, because I want to be there to answer all your questions and just make sure everything's absolutely clear. Again, we're going over critical basic classes, which are going to be incredibly helpful for when we get back, but I need everybody, absolutely everybody, passing attendance and uploading their grades. You have the entire day. The entire day. Don't tell me that at 10 p.m. your cell phone ran out of gas and then you just managed to publish the homework 1 minute late. Well, I'm sorry. That's what happens when you wait till the last minute. Get this done early. Get it over with. Done. No problems. 100. Make sure you work properly at home. Any questions, please ask. Attendance and homework. People stop doing those two things, we're going to be meeting every day for an hour. Or however long class is, at the hour of class. And I don't think anybody wants that, including me. Because I've given virtual classes before, interactive, and they're not very efficient, especially math. So pónganse la pila, get the job done. See you soon. Any questions, please let me know.